In this presentation, the Advanced Correlator Navy Multi-Intelligence Ship Track Data Fusion and associated present behavior pattern of life processors will be described. The Advanced Correlator Navy, or ACORN Data Fusion Processor, has shown excellent results in the detection, tracking, classification, and identification of threats of high interest in 5 Navy Trident Warrior exercises, and in processing sensor data recorded in Western Pacific areas of interest. The present behavior pattern of life processor is designed to collect track data over several years to characterize the behavior of certain ship types, such as military combatants, fishing vessels, cargo ships, etc., in specific fixed areas of interest. Jove Sciences, Inc. is a high-technology company specializing in maritime ship tracking, pattern of life behavior, algorithm development, oceanography, underwater acoustics, ASW, Arctic acoustics, ocean wave energy, quantum computing, and many other areas. The recent success of the ACORN processor on major data from adversary naval combatants has led to a significant increase in funding levels, and Jove desires a teammate to help market the successful technology and transition this technology via SBIR Phase 3 contracts. Jove has senior programmers and analysts with top-secret sensitive compartmented information clearances and a most valuable cooperative research and development agreement with the Naval Information Warfare Center Pacific, which allows the recording of many satellite and tactical data worldwide at any time and in any area. The detection, tracking, classification, and identification of adversary naval combatants and their support ships hiding among commercial ships and shipping environments is a critical current DoD capability gap being successfully addressed by the ACORN and pattern of life processors. The NAVSEA IWS-6 program of record has funded Jove with a SBIR Phase 2.5 contract to ingest the Collaborative Engagement Capability, or CEC, composite ship tracks, and data fuse them with ACORN tracks for DoD missions. This ACORN CEC data fusion capability will have commercial applications, such as the detection, tracking, and classification of IUU fishing vessels, drug runners, pirate ships, illegal arms carriers, and other applications as depicted on this view graph. This effort is showing excellent progress to date. Jove is demonstrating the capability for both CEC and commercial applications. As this view graph shows, the ACORN data fusion processor and its associated pattern of life processor are connected. The ACORN data fusion processor ingests numerous sensor sources, including the integrated broadcast system data feed. The primary objective of the ACORN data fusion processor is to output accurate multi-sensor tracks to both the Navy operator and the pattern of life processor. The pattern of life processor calculates the ship track statistics and detects 7 types of anomalous behavior events. For AIS ships, these events are: 1. Using a bogus ship name, or MEMC number. 2. Going AIS dark. 3. Broadcasting position reports showing excessively high speeds. 4. Frequent changes in course and speed. 5. Rendezvous at sea. 6. Spoofing ship type. And, finally, operating out of the ship's normal ocean area. Currently, data fusion processors output tracks, but do not input them into a pattern of life processor and store them in a database as shown in this data flow diagram. Jove is designing a worldwide system where all ships would collect track data for a pattern of life database. An onshore processing facility would integrate the data into a single pattern of life database for specific ships. The pattern of life processor for ships emitting ELINT and not AIS messages can be covered at a classified level. Currently, the ACORN data fusion processor is written in Java and has been tested at sea on many datasets. A sensor adapter for the IBS data has been written in Java code to strip out ship data for processing by the ACORN radar L0 filter, or AREF, which declutters the commercial track data and classifies other contacts of interest. The Acorn Radar L0 filter is written in Python code and soon will be converted to near real-time software integrated with Acorn. Another set of code upstream computes course and speed statistics for every ship being tracked, and these track statistics are stored in the dynamic AIS ship matrix at the end of each ship's voyage. The static AIS ship matrix has one row for each individual ship in the world and stores over 100 columns of static information about each ship. The ship track shown in this view graph is one of a fishing vessel, showing the frequent changes and course and speed in the fishing area. This track was buried beneath a heavy shipping lane, where numerous cargo and tanker ships were on steady great circle courses with rather constant speeds. The upstream processor produces histograms of each ship's average course and average speed statistics. All the ships exhibiting frequent changes in course and speed, typical of fishing vessels in the fishing areas, are easily extracted from the massive number of ships on great circle routes through the area. Over many years, the storage of the ship track statistics with the other metadata about the ship produces a pattern of life for each ship type in a specific area as a function of time of year. The database of frequent flyers in the area is valuable as a background for detecting abnormal behavior for ships entering the area for a first time, or for ships with no patterns performing unusual tracks. The key advantages of the Acorn Data Fusion Processor and the Acorn Radar L0 filter are threefold. First, the Acorn Radar L0 filter filters out commercial-only ship tracks, greatly decluttering the ship track data. Second, the Acorn Data Fusion Processor fuses IBS ship tracks with other sensor source tracks that are not included in the IBS data feed. Third, the accuracy of the Acorn Data Fuse tracks have been assessed to be very good in 5 Trident Warrior exercises using Navy ground true tracks provided. The key advantages of the present behavior pattern of life processor are fourfold. First, the present behavior processor detects 7 types of anomalous behavior without requiring years of recorded ship track data. Second, the present behavior processor identifies AIS ships by ship name or MEMC number and ELINT ships by ship type or class. Third, upstream calculates in real time the statistics of each ship's course and speed, and outputs histograms identifying ship patterns such as naval combatants on patrol, fishing vessels, and fishing areas, cargo and tanker ships executing great circle routes, etc. Fourth, a static and dynamic AIS ship matrix provides a long-term historical database of ship tracks to establish normal and abnormal behavior. The transition of the Acorn Data Fusion Processor and the present behavior pattern of life processor to programs of record is well underway. The Acorn CEC Data Fusion Processor is now being tested for transition to the IWS-6CEC program into several commercial applications. The same technology is being transitioned to the NAV Air Minotaur program of record and to the PMW-150 Command and Control Experimentation program of record. In addition, NAVC IWS-5 is interested in acoustic non-acoustic track data fusion, since this is a current critical capability gap. Also, the Army JADC-2 Tactical Ground Station Program of Record and STRATCOM are pursuing discussions for the transition of the Acorn and present behavior pattern of life processor capability to their respective programs of record. The DoD transition for the Acorn and present behavior pattern of life technology has been discussed in detail in previous view graphs. The current commercial market of this technology is potentially large. Illegal fishing is a $100 billion market for which the Acorn and present behavior pattern of life processors are critically needed. Pirate ship activity is increasing, especially in areas like the Red Sea. Illegal drug trafficking is widespread, with drug routes from Colombia and Peru, as well as from Pakistan to destinations all over the world. Illegal maritime weapons trafficking is also widespread, with countries like Iran, North Korea, China, and Russia supplying weapons to terrorist groups all over the world. Jove is having discussions with Southcom and Fourth Fleet concerning the critical illegal fishing currently occurring in the Gulf of Mexico. There are literally hundreds of similar commercial problem areas where Jove's technology is critically needed. The conclusion is that the Acorn data fusion processor and the present behavior pattern of life processor are being transitioned into several Department of Defense programs of record, and that this technology adds significant capability to solve illegal fishing, drug running, pirate ship, illegal weapons trafficking, and other commercial applications. For further information, please contact Dr. James H. Wilson. His contact information is listed on this slide.